Alright, let's do some acceleration problems. Alright, here we go. We're in chapter 12, or chapter 2 here. Let's go. The velocity of a car decreases from 30 meters per second to 18 meters per second in a time of 4 seconds. What is the average acceleration of the car? So the equation for acceleration, one of them that we have, is the acceleration equals the final velocity minus the initial velocity divided by the time. Okay, so let's write out the things that we have. Decreases, so it starts out at 30 meters per second, so that's VI, 30 meters per second. And it goes to, so the final velocity is 18 meters per second. And it does that in a time span of 4 seconds. We are looking for the acceleration. That's the unknown. So acceleration, we don't know what it is. The unit for acceleration is meters per second squared. Everything's in meters per second or seconds, so we're good there. If we had something like in kilometers per hour, we would have to convert that to meters per second because we usually put our acceleration in meters per second squared. Alright, so all we have to do really is plug in the numbers into the equation. We have a VF of 18 meters per second, and we're going to subtract 30 meters per second because that's our VI. Then we're going to divide by a time of 4 seconds, and that's equal to our acceleration. Now I'll go ahead and work part of this out for you. Let's bring up the calculator. So we go 18 minus 30 equals a negative 12. So we have negative 12 meters per second over 4 seconds. Now, you're probably saying to yourself, our acceleration is negative. We have this negative sign here. That's okay. You can have a negative acceleration. That just means you're slowing down. And if you look, you're going from 30 meters per second to 18 meters per second. You are slowing down. So a negative acceleration just means you're slowing down. A positive acceleration means you're speeding up. That's all. And if you look at the units here, you have meters per second divided by seconds. So meter per second, and then you divide by, or just multiply it by 1 over second. You're going to end up with meter per second squared. That's exactly what we want for the unit. So 12 divided by 4, negative 12 divided by 4 with a unit of meter per second squared is your answer. I'll let you plug that into your calculator or solve it in your head. Let's do another one. Acceleration. A steel ball is dropped from a diving platform. We don't know why, but it is. And we're going to use the acceleration due to gravity, g, acceleration due to gravity on Earth, 10 meters per second squared. They rounded up. That's fine. It's normally 9.81 meters per second squared, but here we're going to use just 10. What is the velocity of the ball after 0.8 seconds of it being released? Now we can't, but we're going to rearrange our equation from last time into this. I gave you this in the notes. Our final velocity is equal to our initial velocity plus AT. That comes from this equation right here. So I just have it rewritten for you. Another one that you need to write down is this one right here. We're going to use it here in a moment. But for this example, we're just going to use this guy that I have circled. Okay, so what is the velocity of the ball after 0.8 seconds? So we have, let's write down the things that we have. We know that the VI for, let's call this A, this one's B. For A, the VI, if it's being dropped, it's 0. We know the acceleration due to gravity, so acceleration, G. So you can write G or A is 10 meters per second squared. We know the final velocity, or no, we're looking for the final velocity. We don't know what that is. We do know the time, 0.8 seconds. So 0.8 seconds. Alright, so all we have to do is plug into this equation here because we're solving for VF. So VF will equal our VI, which is 0, plus A 10 is a, so remember this just stands for acceleration due to gravity. That's what this G stands for. So 10 times 0.8. That is your answer right there. Take 10 times 0.8, and that would give you the VF. Our initial velocity is 0, so we don't have to worry about that. That goes away. So 10 times 0.8 is, and remember that's going to be in meters per second, because this is meters per second squared, this 10. That 8 is seconds. So if you take meters per second squared times second, your unit should be meters per second, and that's what we want for velocity. Okay, let's do B. B is going to be exactly the same, except our time is 1.6 seconds. Our VI, ball's just dropping, is 0 meters per second. Our acceleration due to gravity is 10 meters per second squared. Our VF is what we're solving for. We don't know what it is, but hopefully it's going to be in meters per second. So you just plug into VF equals 0 plus 10 times 1.6, and there's your answer. I'll let you plug that into your calculator. Again, the answers will have the units of meters per second. Meters per second. Okay? So just make sure you include that in your final answer. Alright, let's try to fit one more in. Through what distance does the ball from E2 fall in the first 0.8 seconds? Okay, so this time we're solving for distance. Back here we solved for VF, now we're solving for distance. We're going to, in B, how far does it fall? Okay, so we're going to do 0.8 seconds and 1.6 seconds. So let's do A first. The time. Write out everything we know. Here's the equation we'll use. I know this is the equation because after I write out my knowns and unknowns, it has the variables that I want. So 0.8 seconds, my VI, it's being dropped, so it's 0 meters per second. The acceleration is 10 meters per second squared. I got that from back here. It's always the same, acceleration due to gravity. Okay. So I want to know for A, board over a little bit. Okay, for A I want to know the distance. Alright, so that's why I'm using this equation. I need distance. I need it. I have VI. I have A, acceleration. I have time. That's why I'm plugging into this equation. So you write out your variables first, and then you pick which equation you want. That's how you normally do it. I had them written down already, just for convenience. But that's how I do it. Write down your unknowns and your knowns, and then you choose your equation. So let's just plug in. It's already solved for D. So D equals VI is 0 plus 1/2 times my acceleration of 10 times t squared, which is 0.8 squared. So I'll work this one out for you. You're going to take your 0.8, square it. Okay, then we're going to multiply by 10. Then we're going to multiply by 1/2. And you should get, and then we'd add 0, which just doesn't change it. 3.2. Now this is distance. So this unit's second squared times meters per second squared. This has no unit on it. This is just 0. So meters per second squared times second squared. So meters. That's what we wanted. Alright, and everything was in the correct units as well. So if you don't know what I'm doing over here, just look at the units. Make sure you're in seconds and meters per second squared, and your distance will always be left with meters. Okay, let's stop there.